Hello and welcome to Commerce Online Academy. In today's lesson, we want to look at Venn diagrams that contain two sets, that is two subsets in the universal set. We have introduced the concept of Venn diagram, and we also looked at an example of Venn diagram in our last lesson. In today's lesson, we want to look at additional examples on Venn diagrams containing two sets only. We want to organize this topic as much as possible, which means that we are going to be studying Venn diagrams with two sets, then we go to Venn diagrams with three sets, and then we progress as the complexity increases. So let's look at this example. In a class of 70 pupils, if you have 70 pupils, that means that 70 is the universal set. In a class of 70 pupils, 36 like Tasty Tom. We have 70 pupils in the class and 36 like Tasty Time. Tasty Time, I think, is one of the food for kids. Okay. Then "34 like ice cream", 36 like Tasty Time, and 34 like ice cream. Now 6 like both Tasty Time and ice cream. 6 pupils like both Tasty Time and ice cream. So 6 like both. Now the question is that we should draw a Venn diagram to show the data. Draw a Venn diagram to show the data. Solution. We say that the universal set is represented with rectangular box. So this rectangular box contains all the pupils, which is 70. Then we have two sets of pupils in the class, those that like Tasty Tom and those that like Tasty Time and those that like ice cream. Then we also have those that like ice cream and Tasty Time. That is the intersection of Tasty Time and ice cream. Like I said in the previous lesson, that the intersection, we always start with it. When we represent the intersection or find what is there in the intersection, then we subtract the intersection from the sets, from each of the sets, to get the part that is remaining there. Now this say that 6 people like both tasty time and ice cream, so we put 6. We start with 6. Now let's call tasty time T, and let's call ice cream I. They say that 36 like tasty time. That 36 means the whole of this circle. The whole of this circle is 36. So out of the 36, 6 are within the intersection. So to find the remaining part of the circle, it is going to be 36 minus 6, which is going to be 30. Then for the second set, that is for the ice cream, we have total of 34 students, 34 pupils, and 6 already are in the intersection. So to find the remaining part of the circle, it is going to be the total circle, or the total people in the circle, minus the people in the pupil in the intersection, which is 34 minus 6. 34 minus 6 will give us 28. Okay, so this is the representation of the data using Venn diagram. Now, question number 2 in this example says that we should find how many pupils that like neither tasty tom nor ice cream. How many pupils like neither tasty tom nor ice cream? Now, let's call those pupils X. That means that they are neither in set T and set I. They are neither in set T nor in set I. They are totally out of the two sets, which means that they are the complements of the two sets. So we have, let's call it X. So X number of pupils like neither tasty time nor ice cream. Now, just like I said in the last lesson, to solve for X, we equate everything to the universal set, everything inside the universal set. We equate it to the number of elements in the universal set, which is 70. So we are now going to say that 30 plus 6 plus 28 plus X is equal to 17. So with this we solve for X, and that will give us that X is equal to 30 plus 6 plus 28 will give us 64. And so x is equal to 70 minus 64. 70 minus 64 will give us 6. Seventy minus 64 gives us 6. So the number of students, the number of pupils that like neither tasty time nor ice cream is equal to 6. So this is how to solve this question. Now let's look at another example. In this example, we have that in a class of 81 pupils, in the universal set we have 81 pupils. "55 of whom are girls." 55 of them are girls. Now, 42 pupils, including all the boys, are day students. 42 pupils, including all the boys, are day students. Are they students? That is in bracket, including all boys. Now, draw a suitable Venn diagram to show this information. We start with our universal set. The universal set contains 81 pupils. Then in this universal set we have girls, and the girls there is 55 pupils. Let's not write it until we get the intersection. So the intersection, we have some girls that are day students, and there are girls that are not day students. In every class that involve pupils, if we have boys, the pupils can be either boys or girls, or boys and girls, or girls alone. Here they've told us that we have boys and girls. So girls alone are 55, and some of them are day students, and all the boys are day students. So let's represent this. Let's have this as boys, there is an intersection between the boys and the girls for the day students. So let's call the intersection, let's call it X. That is the portion of the girls that the intersection represents the portion of the girls that are included in the day students. So this X and all the boys are day students. So the boys are here. How do we get the boys? Let's call these boys B. Let's call the boys B. The number of boys, let's call it B. Now it means that since they say that the total number of day students is 42 and all the boys are included in the 42 plus the portion of the girls, which is X. Now it means that 42 is equal to all the boys plus this X. So now let's say now that B is equal to 42 minus X. B is equal to 42 minus X. That is the portion that is representing girls in the intersection. That is X. And then 42, which include all the day students, which involve all the boys. So now we have that we can now put here this B. Now we write 42 minus X. So 42 minus X, and this side of this set for the girls, this is for boys and this is for girls. Now for the girls, the remaining portion of it is the total number of girls minus X, which is equal to 55 minus X. 55 minus the girls in the intersection. Now to solve for X, we have that everything inside the universal set is equal to the total number of elements in the universal set, which means that 55 minus X plus 42 minus X, everything will give us 81. This, if we add it to give us 97, this cancel this, 97 minus X is equal to 81, and so X is equal to 97 minus 81. and this gives us 16. So 16 is the number of students or number of pupils that are 16 is the number of students, the portion of girls that are there students. So this is how to solve for this. The portion of girls that are day students is equal to 16, and that represents what is there in the intersection of the boys and the girls. Now let me say something that is general about sets with Venn diagrams with two sets. If we have a Venn diagram with two sets, the total number of elements or values in the set given is always more than the universal set. What I mean is this, like in the example given in the quiz given in the last lesson, if you solve it correctly, you are going to get a negative value. Now that negative value is showing that we don't have enough samples within the universal set to make up for the value outside it. So when the number of elements in the sets within the universal set is not enough, it will be negative. It will give you a negative number. So to make sure that you don't get a negative number for the examiner, not the student, the examiner will make sure that the number of the value in the universal set, inside the universal set, is more than the value outside the universal set. Like when we have that in a Venn diagram where we have two sets, and we have this one as we have this place as 4 minus x, and we have this place as x, and we have this place as 2 minus x, and we have this place as 1, and then we have this place as 10. Now if you look at this, this is 4, this is 2, and this is 1. So everything inside the set is not up to 10. If you solve this, you are going to get negative number. So the examiner, to avoid the students from getting negative number, or to make sure that the question is more accurate, you should make sure that this number inside is more than the number outside, because actually in a set you shouldn't have a negative number. In a set you shouldn't have a negative number, but if you have it, it doesn't actually mean much. What it means is that you have not given enough data inside the set, inside the universal set, to account for the value that is outside the universal set. So that is the implication of getting a negative value when you solve for anything inside the universal set.